that you are not going to confuse lesson 7.3 with 7.2 because we're still multiplying, but it's going to look a little different. So let me do a really super quick review. 7.2 lesson was something like x squared times x to the fifth. And so these were separated out bases, and if the bases were the same, you could have added their exponents, so it would be x to the seventh. Okay, today we're still multiplying like we were here. However, there's not separated out bases like there were here. Today, I want you to look at that your first one is only one base, and it's raised to a power and then raised to another power. So we call this raising a power to a power. So when you raise a power to another power, instead of getting added, like in the previous lesson, these are going to get multiplied. So 5 times 2 is going to be x to the 10th. Okay, please don't confuse that with if I had have separated out x to the 5th times x squared. That would be x to the 7th. However, if you're taking the entire x to the 5th and squaring it, I want you to see what that looks like. That looks like x to the 5th, 1, 2, 3, 4, 5, twice. 1, 2, 3, 4, 5. So if you count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are 10. Whereas with the ones that we did previously, there were 2 here and there were 5 here. So that's 1, 2, 3, 4, 5, 6, 7. So please know that this is a total of 7 things x is getting multiplied because they're separated out, bases are the same, you can add their exponents. But when you already have 5 x's and you're doubling the set of 5 x's, that is when you can go ahead and multiply the exponents and get 10. Okay, big difference here. A lot of kids confuse these. Please be very careful. We're not going to do fractions, rational numbers. You will in Algebra 2, so get ready for that fun stuff. But these notes are here in case you want to check them out. But for our purposes today, we will just be doing problems that look like number 1. So let's jump down here to 1a. N to the 4th raised to the 7th. That means 4 n's being multiplied, and then 7 of those 4 n's that are multiplied. So you can multiply 4 times 7, which would be n to the 28th. Okay, if you know the rule, you can go ahead and start multiplying. P to the 5th to the 4th is p to the 20th. Okay, here's something interesting. These are separated out. We're going to add those later. But first you have to look at if there's any powers raised to another power, because just like in PEMDAS, in the order of operations, you have to multiply exponents first, and then we can go back and see if we have any bases that are the same to add. So I'm going to first bring down this x squared, and I'm going to look at it later. This x to the 6th to the negative 4th is going to be x to the negative 24th, because 6 times 4, negative 4 is negative 24. Now we have back to 7.2's lesson that I reminded you about up here. If you have numbers with the same base separated out, you can add their exponents. So 2 plus negative 24 is negative 22. And I would normally say go ahead and circle that, but we just really need to keep reviewing so that you keep practicing when you have a negative exponent. It's not simplified. So I really want you to flip it under a 1 and make it x to the now positive 22nd. Let's just keep reviewing that skill. Anytime you see that as often as possible, it won't feel new or like you forgot when you see it again later. Okay, let's go down here to look at number 2. This is a word problem. It's saying, look at this square over here. One side is 5x to the 3rd. What is the area? So in case you forgot about area, that would be length times width. And if it said it's the word is square, I hope you remember that squares mean it's the same on this side as it is on this side. So this is also 5x to the 3rd. And if it's length times width, I'll go ahead and remind you up here, to find the area, which it says area, then I need to multiply 5x to the 3rd times 5x to the 3rd. So that looks like this. 5x to the 3rd times 5x to the third. Okay, this is really more of a review of yesterday's lesson because you can go ahead and multiply your bases, which is 25, and then these are separated out. They're the same base. So it is x to the 6th, and this is the final answer. It's D. What you might have wondered, if it's since it's 5x to the third and it's 5x to the third again, it could have been written like this. And that would be squared to the next power. And then you would have had to have known that this little 2 actually does go to the 5 and it goes to the 3. 5 squared x to the 6th, which 5 squared is 25. X to the 6th, which is what we got, we just did it a different way. So we're going to do more of this where you kind of distribute that little power to each of the terms inside parentheses right now, actually. That's what this whole bottom section is about. So let's look at number 3. Negative 2 times positive 2 is negative 4. So x to the negative 4. Let's just leave it like that for a minute. Over here, you have a 4 that is going to have to go to every single term inside the parentheses. So the reason we didn't do this earlier is because there was only one thing in the parentheses. It was only n, so it just was n to the 28th. It was only p, so it's just p to the 20th. And x was only being raised to the 6th and to the negative 4th, this one, because it's the only one that was in parentheses. Down here, we've got all of these terms that are all in the parentheses getting distributed the 4. So first it's going to look like 3 to the 4th power, because that exponent attaches to the 3, and it attaches to the x, and it attaches to the y to the 5th, which means they get multiplied, so it would be y to the 20th. Oh my goodness. Okay, same bases, their exponents can get added. So negative 4 plus positive 4 is 0, which is 1. Thankfully, those are going to go away because negative 4 plus positive 4 is 0, and anything to the 0 power is 1. So we've got 3 to the 4th, y to the 20th. I'm going to go ahead and have you guys simplify out 3 to the 4th. If I'm going too fast, please slow the video down or rewatch it, rewind, try it again. 81. So 3 to the 4th is 81. Y to the 20th is going to have to stay y to the 20th because I don't know what y is. Okay. This little 3 exponent is going to have to go to the 6 and the a and the b. So what we've got is 6 to the 3rd, a to the 3rd, b to the 3rd. This little 2 is going to have to go to the 5 and to the a to the 3rd. So that looks like 5 squared. A to the negative 3 times 2 is negative 6. Okay, I'm going to look at combining my bases. We have a to the 3rd and a to the negative 6th. You can add those exponents, which would be a to the negative 3rd. B to the 3rd, I'm going to cross those off because I'm starting to get confused with what I've already used. B to the 3rd has no other bases that are the same, so it's just going to be b to the 3rd. We've got 6 to the 3rd in here, and we've still got 5 squared in here. So I'm going to go ahead and simplify 6 to the 3rd and 5 squared. 6 to the 3rd is 216. This is going to be an awesome number. 5 squared is 25. A to the negative 3rd, b to the positive 3rd. So we can go ahead and multiply 216 times 25, which is 5,400. Awesome. I'm running out of room. 5,400. And I'm going to go ahead, if you guys are okay with it, and now move the a to the 3rd to the bottom so it can become a to the positive 3rd because you can't have negative exponents. But b to the 3rd was fine up top. There's nothing wrong with it, so it's going to stay up here. So this is my final answer. That was a lot of work. All right. Oh, thankfully, this one's just the only thing that gets the 6 is the n to the 3rd, which makes it n to the 18th. Whew, I like those. Same thing here on D. So these are the only thing that gets multiplied, making it b to the negative 21st. Oops, almost done. Can't have a negative exponent. I'm going to flip it to the bottom and make it 1 over b to the positive 21st. Okay, these get multiplied. These get multiplied. Let's see what we have. T to the 2 times negative 2 is negative 4. t to the 2 times negative 5 is t to the negative 10th. These are the same base, so we can add their exponents, which would make it t to the negative 14th. Unfortunately, you can't have a negative exponent, so it's 1 over t to the positive 14th. All right, I'm going to try to beat the bell because they're about to start dismissing students. So here we go. I'm going to go a little faster. Sorry if it's too fast. Negative 4 goes to the 3 and to the n to the negative 6th. So that would be 3 to the negative 4th, n to the positive now 24th, because a negative times a negative is positive 24. This is not okay, so it's going to flip to the bottom and become positive. So my final answer is n to the 24th over whatever 3 to the 4th is. 81. Okay. The negative 2 goes to the 7 and to the a, so it's 7 to the negative 2, a to the negative 2. They're both negative, so they're both going to flip under a 1 and become positive. 7 to the 2 you can work out, 7 squared, which is 49. So the final answer is 1 over 49a squared. All right, h. 3 squared is not getting distributed because it's not in those parentheses, but this little 3 is going to go to both of the things that are inside the parentheses, which means 3 is going to get the third and x is going to get the third. And now I'm just going to say, oh, these have the same base. So I can go ahead and say I'm adding their exponents, and that would be 3 to the 5th, x to the 3rd, and I can actually go ahead and solve what 3 to the 5th is. I know it's probably going to be big, but, oops, 243, it's not too big. So 243, x to the 3rd. Almost done, we're going to get it. All right, this little 2 goes to everything inside the parentheses. So it goes to the negative 5 and to the x. I'm just going to bring this part straight down. Negative 5 squared is positive 25x squared, and then we've got 5x squared here. This is a little bit ahead, but this is kind of a bonus. So I'm going to go ahead and tell you this, even though if you're confused by the rest of it, maybe this is too much for you today. But you can only combine terms that are like. You can only combine like terms. And if this is an x squared on 25 and this is an x squared on 5, they are considered like terms. So you can go ahead and say that 25x squared plus 5 more x squareds would be 30x squared. And we'll do more of this later, but this is just kind of a heads up on what's coming.